All right, so a quick review of what we talked about on Monday. Natural monopoly occurs when there is an organization that can provide all of the product or service that a given market might demand. And so the example we talked about was like town water. Electricity is another good example where there's a really high fixed cost of providing that service, but there is a declining average total cost over the region, over all the possible quantity. So why would somebody enter into trying to provide water, for example, to a town when there's already somebody else doing there? What would happen is you'd have to try to split the quantity, which would just cause the price to go up. But whoever's there already could just cut their price down towards their average total cost and undercut you, and they could just keep always undercutting you. So it doesn't. So that's what we call a natural monopoly, which is when, again, there is falling average total cost over the relevant range of quantity. So, and a monopoly is when we have one provider who's able to provide all of the services to the market. But what that then gives the provider is pricing or market power, which allows them to choose at what price level they want to operate at. So we talked about perfect competition in chapter 11, where the market, the sellers and buyers in the market faced a fixed price, which became their marginal revenue. Monopolists face our traditional demand curve that we'd been talking about up until chapter 11, where it's a downward sloping demand curve. So monopolists, because they are price makers, right, and consumers are price takers, the monopolist gets to choose. Do I want to set a price at P1 and sell a little? Do I want to set a low price and sell a lot? They're going to make that decision based on maximizing their profits. Right. And so we're going to get into, as we go along, we're going to get into how do they go about doing that? Well, and I'll give you a hint. They set marginal revenue equal to marginal cost, just like we did in chapter 11. Right. So, but it's going to look their marginal revenue is going to look different this time because their demand curve that they face is this downward sloping demand curve instead of a horizontal demand curve. So when we said, and this is where we cut off last time, let's assume that let's assume that we're operating with a demand curve, right, where D is P equals 10 minus Q. So a really simple demand curve. D equals 10 minus, D equals P, D is P equals 10 minus Q. Let me just start that over. So we have P equals 10 minus Q. That's our demand. We know total revenue is price times quantity, right? So if we know that price is 10 minus Q, we can substitute in 10 minus Q for price and then times Q, right? And so we can say, okay, total revenue is 10 minus Q times Q, and we can distribute the Q through there. So 10 times Q is 10Q minus Q times Q is Q squared. So total revenue is 10Q minus Q squared. And then we can say, all right, if we know what we know is total revenue, if we know total revenue is 10Q minus Q squared, then we can calculate marginal revenue by using the power rule, right? And so we look at this first term and we say, okay, that's really 10q to the first power. So we bring down the 1, right? Then we bring down the 10. Then we bring down q to the 1 minus 1, right? And then we can move on to the second term, which is minus. So we bring down the 2. Then we bring down the q, and then there's a implied 1 here, so we don't really need to do that. Then we bring down the q to the 2 minus 1. So now we've got q to the 1 minus 1 is q to the 0, and we know q to the 0 is, no, q to 0 is 1, right? So we have 1 times 10 times 1, which is 10, and then 2q to the 2 minus 1, which is q to the 1, which is q, right? So our MR is 10 minus 2q. Right? So we now know our demand, price is equal to 10 minus q. We know our total revenue, which I made a mess of, so I'll rewrite it, is 10q minus q squared. And we know our marginal revenue, which is 10 minus 2q. All right, so let's look at that on an Excel sheet. So if we know T is equal to 10 minus Q, I'm going to type in a formula. I'm going to say, okay, P is equal to 10 minus whatever's in the Q column. So when Q is 0, price is 10. And I'm just going to copy that down. And you can see as I increase quantity, right, where P is 10 minus Q, when Q is 1, 10 minus 1 is 9. When Q is 2, 10 minus 2 is 8, right? And so on down to here where P is equal to 10 minus Q, where Q is 10. So 10 minus 10 is 0, right? So what we see is that declining demand curve like we're used to seeing. So let's look at that real quick, right? So we have P and Q, and we said P is equal to 10 minus Q. So what do we know? We know the intercept on the P axis is how much? 10. We just say, okay, if Q is 0, P is 10. And then solving for P when, solving for Q when P is 0, right? So we say 0 equals 10 minus Q, right? Then Q would be equal to 10, right? So this is, so we have 10 and 10 like so. So we know as price goes down, right, we're seeing an increasing amount of quantity, which is what we're seeing here too, right? So as price goes down from 10 to 0, right, we see quantity increasing. All right, how about total revenue? How about total revenue? We know total revenue is price times quantity, right? Yay. All right, so we'll just do equals quantity times price, and we get 0, right? When 0 times 10 is 0. And we just copy that down. So when price is 1, we sell 9, right? So a total of, so 9 times 1 is 9. When price is 8, we sell 2. So total revenue is 2 times 8, 16. When price goes to 7, we sell 3. So it goes up to 21. When price is 6, we increase our quantity again to 4. So 6 times 4 is 24. When we get down to a price of 5, we're able to sell 5 at 5. That gives us total revenue of 25. And then what starts to happen? We drop the price to 4, right? And we sell 6. Woo, we're selling more. But what's happening to our total revenue? It starts to decrease, right? And then we go to 7 and we sell, or excuse me, then we go down to a price of 3 and we sell 7. Woo, we're selling a lot. We're moving product. But our total revenue is going down, right? So there's an optimal price. What is the optimal price? If you want to maximize your revenue, what's the optimal price? So I want to maximize my revenue, which means I want to have the highest total revenue. 5, right? 5 is where I get my highest total revenue. Okay, so there's this idea here that as price goes down, we're going to sell more units, right? So if we have a maximum price, we're going to sell the fewest number of units, and that doesn't allow us to maximize our revenue. But on the other extreme, if we cut price too much, we sell a lot, but we're not really bringing in much revenue. Where we want to be is at a price that if we're trying to maximize our revenue, we're going to have to find kind of that middle point where we cut price enough that we sell a lot, but not so much. We don't cut price so much that we're earning very little on each unit. Like we say, we're going to, sell. We're going to sell it at 1, price of 1. Lots of people are going to be like, I'll take it at a price of 1, sure, but it doesn't generate us very much revenue, right? Now, businesses don't exist to maximize revenue. If you own this business, your goal would not be to maximize revenue necessarily. What do you want to maximize? You're not running this business because, like, this is not a hobby, right? Let's say this is a business where you are, selling chemotherapy drugs, right? So it's a business that you're doing something that's good for society, but this is not a hobby, right? What do you want by running a business? Profit. Thank you, Kayla. Right? You want to maximize profit. If you can maximize profit by selling one thing, you'll sell one thing, right? You want to maximize profit, not revenues. But we obviously want to know, right? Revenue minus cost is our profit. So we want to find this sweet spot where we generate the maximum amount of profit. But let's figure out real quick, how do we know when we're approaching maximizing our revenue? Because that's a useful thing to know. Well, we know that the marginal revenue function we just said was equal to 10 minus 2 times the quantity. So marginal revenue at 0 is 10. Why? Because if we sell 1, we'll earn 10. At 9, if we sell 1 more, we'll get 8 more. If we sell at a price of 8, if we sell 1 more, we'll get 6 more, so on, right? So we are seeking to get to a point where we can, marginal revenue is how much, if I sell 1 more at this point, how much more would I earn? And so we're seeking to continue to increase our to increase our total revenue. So what we're seeing is early on, our marginal revenue is really high, right? So if we add one more, we're going to have a lot more revenue. We're going to have at 0, if we add one more, we'll get 10 more units, $10 at, if we add 1 unit, if we add more, we have a really high gain. At 2 units, we have a high gain, but less high, and so on, all the way down to 5, where we get to 0. Which makes sense, because after 5, if we add more units, what happens to our total revenue? Starts to go down, right? And so if we keep copying that down, what we see is after the maximum total revenue, marginal revenue becomes negative. If I sell one more at 5, my total revenue actually starts to go down. And as I keep adding more, it goes down faster and faster until I wind up back at 0 again. Okay. So let's look at what this looks like, or let's draw what this looks like. Drawing a different graph. I'm going to do total revenue and quantity. So when when quantity was 0, obviously total revenue is 0. When when quantity is 1, right, we had total revenue of 9, then 16, 21, right? We had 9, 16, 21, 24, 25, then 24, 21, 16, 9, 9, and then 0 again, right? So at 10, we're back to 0 again. So at 1 was 9, right? At 5 is 25. Right. And then, so what we have is total revenue that rises, then falls again, like so. Right. So maximum revenue is here at 5, right? It peaks at 5. Marginal revenue is that, remember, marginal, when we talked about marginal cost in chapter 11, we had total revenues, and we had a constant price, right? Total revenue went up like this, and then we were looking at total cost, and we were looking to find the tangent line to the total cost curve that was parallel to the total revenue curve, right? So this was the formula for this tangent line was marginal cost. We can do a similar thing with marginal revenue here, and we could draw tangent lines at each of these points, and that would give us our marginal revenue, right? So we said at 1, our marginal revenue is 8, right? At 2, our marginal revenue is 6, right? And so on until we got to 5, where marginal revenue is 0. So MR at the top is 0. So the slope of the horizontal line is 0, right? So that's how we know we're at the top of the maximum revenue, is when marginal revenue equals 0. Okay. So if you want to find maximum revenue, right, you're going to solve for a quantity where marginal revenue equals 0. So if we know that our MR function is 10 minus 2Q, and we want to find what is the maximum, the quantity that maximizes revenue, right? We set MR equal to 0 and we say 10 minus 2Q, right? We add 2Q to both sides, we get 10, Q is equal to 5, right? So that is Q for max revenue, right? So when MR equals 0, right, then Q will give us max revenue, right? Okay. So now let's graph MR, marginal revenue, with our price. So if we know MR equals 10 minus 2Q, right? And we're going to graph MR on this axis. When Q is 0, MR is 10, right? If I set Q to 0, that means that goes to 0. And so now I've got an MR of 10. When MR is 0, we just said Q is 5. So that means MR crosses the Q axis at 5. And we know wherever the quantity that MR crosses the Q axis at is going to be the quantity that maximizes revenue, right? So if we know that the value where MR is equal to 0, we can say, well, that's the price that maximizes revenue, right? And so if we know that 5 is the quantity that maximizes revenue, we can plug it into our demand function and figure out what the price would be. So 10 minus 5 equals 5, which we already know from the Excel sheet we just did. So now we're able to draw both the demand function as well as the marginal revenue. All right. Let's work just a quick variation. Let's say, just for practice, let's say that our demand curve is P is equal to 50 minus 1/2 Q. What would our total revenue be? Let's start with that. What's total revenue? What's the total revenue function? And then if you get that, figure out what the marginal revenue is. Remember, it's P times Q, right? And this is equal to P. And if you get that far, then figure out what the revenue maximizing quantity is, right? So that's where we're going. So if you want to keep going, you feel like you're good on this, the next step would be get me total revenue, marginal revenue, and then the revenue maximizing quantity. So what do I do? Molly. Mm-hmm. Good. Everybody got that? All right. Then we're going to go from there to our marginal revenue. So who can help me get the marginal revenue? Somebody other than Molly. Okay, so the 1 comes down times 50. Which is what? Which is also 1, right? Okay, keep going. Good. So we have 50 minus 2 times a half is 1 times q to the 2 minus 1 q, right? So the MR is 50 minus q. And then what is the revenue maximizing quantity then? I set, to get that, I do what with MR? I set MR equal to 0. So 0 equals 50 minus q. What's q? 50. Good. All right. So let's take that and plug it into total revenue then. TR equals 50 times 50 minus 1/2 50 squared. That'll give us our max revenue. So this is going to be 2,500 minus half of 2,500, which is 1,250, right? So that's 1,250. Right, 50 times 50, 2,500. 50 squared is also 50 times 50, which is 2,500. Half of 2,500, 1,250. So 2,500 minus 1,250 is 1,250. If we were to put in, just to kind of prove the point, if we were to put in, say, 51, right, which I can't do in my head, but 50 times 51 minus 1/2 51 squared, so 51 squared is 2601 divided by 2 is 1300.5, right? And 50 times 51 is 2550 minus 1300.5 gives us 1249.5. So it's not a big difference, but it is less, right? That's the point. So we do one more, we go up from 50 to 51, we have a reduction in revenue. So we definitely don't want to produce more. We don't want to produce, if we have a choice of how much to produce, we may not want necessarily to produce where our revenue is maximized, right? We might actually want to be back here, but we don't want to be on this side, right? We don't want to be on this side because we're making less product. So we're going to want to be to the left of the Qmax revenue. All right. So now, how do we know how much we actually do want to produce? Well, we need to have what? What do we need? To figure out our profit maximizing quantity, we set MR equal to MC. So we need MC, right? Let's assume for a minute that our total cost function is something super simple, like 2Q. Right? Which is, possible in kind of a made-up world where, you have no fixed costs at all. But just for purposes of making this really simple to work. So if I've got a total cost function of 2Q, what's my marginal cost? Two, right? Because I take, that's Q to the 1, so the 1 comes down, right? 1 times 2 times Q to the 1 minus 1 is 1 times 2 times 1, which is 2. So the MC is 2. So if I'm going to put MC on this y-axis now, what am I going to draw? Molly. From 2 on the p-axis, right? A horizontal line starting at 2 on the p-axis. So it'd be like this. Okay. So now I'm going to set MR equal to MC, right? So MR is 10 minus 2Q. So MR is 10 minus 2Q, and MC is 2. Now it's a super simple, solve. So I subtract 2 from both sides, add 2Q to both sides, I get 8 equals 2Q. Then divide through by 2, and I get Q is equal to 4. Okay. So if the profit maximizing quantity is 4, what's the price we're going to charge? I'm going to produce at 4. I'm going to produce 4 units. So what price am I going to charge? Well, I'm going to follow that 4 up to the demand curve, plug it into the demand curve, 10 minus Q. So P equals 10 minus 4, 6. All right. And we know, we know that 4 is going to generate less revenue than 6 would have. Sorry, than 5 would have, right? 4 units is going to generate less revenue than 5. We said that just a minute ago. We looked at it when we calculated all the total revenue. So we're actually opting to produce less total revenue. Why? Well, it costs us $2 to produce each unit, right? Because the total cost is 2. So the marginal cost is 2. So every time we make something, it's 2. But from going from 4 units to 5 units, at 4 units, how much revenue do we make? Revenue is price times quantity. So at 4 units, how much revenue do we make? What's the price at 4 units? 6, right? The price is 6 at 4 units. So how much is the total revenue? 24. Good. 24 units, right? Sorry, $24. So we're making $24 at 4 units. If we go up to 5, we'll make 5 units at a price of 5. That's how much total revenue? 25. What's the cost? How much additional revenue did we get here? By going from 4 to 5, how much additional revenue do we get? How much did it cost us to go from 4 to 5? No. What's our marginal cost? 2, right? So going from 4 to 5 increases our total cost by 2. but we get one more dollar of revenue. So revenue goes up by 1, cost goes up by 2. What's happened to our profit at that, going from 4 to 5? Just that range. We had a $1 increase in revenue and a $2 increase in in cost. So we lost $1 in profit, right? $1 of revenue, $2 in cost. Our total profit actually goes down by $1 by producing that 5th unit, right? Because we got plus $1 in revenue and minus $2 in cost gives us -1 profit, going from 4 to 5. So it doesn't make sense to produce that 5th unit because that'll actually cost us more cost than we get in terms of additional revenue. Our additional cost is greater than our additional revenue. So what is our total our profit at 4? Well, profit equals total revenue minus total cost, right? So we know that total revenue at 4 is 4 times 6. That's this box here. And our total cost, we said, is 2Q. So that's 2 times 4. So we get 24 minus 8 is 16. If we were to go up to 5, we already know it's not gonna make us more money, but if we would go up to 5, we'd get 5 times 5 minus 2 times 5, right? So 25 minus 10, 15 profit. So if we go from, at 4, we're making a profit of 16. At 5, we're making a profit of 15. And where would we rather be, Kayla? 4 or 5? 4, because we make more profit, right? Kayla is the profit of profit, right? So, and if we go to 3, what happens? You say, well, making less obviously is more beneficial. Let's make less. All right, well, 3, at a price of 3, excuse me, at a quantity of 3, our price would be 7. So total revenue would be 3 times 7 minus 3 times 2. 21 minus 6 is 15. So either side of 4, we're making less money. We're making less profit. And we want to maximize, our goal is to maximize profit. And so here, one other thing I want to make point of, what's average total cost? If total cost is 2Q, average total cost is total cost divided by quantity. So what is average total cost? 2Q divided by Q gives us 2. Thank you. So in this case, in this very special case, where we have no fixed cost, and our quantity is not being raised to a power, or it's being raised to the power of 1, we have a situation where marginal cost is equal to average total cost, right? So you could say my costs are at 4, my total revenue is this box, right? And my costs then, average total cost, right, at 4 is this. The red is my total cost, right? The whole box is my total revenue. And then what is this, what does that mean this box is? The whole box, price of 6, quantity of 4 is my total revenue. And the smaller box that I colored in red from a average total cost of 2 and a quantity of 4, right? That's my total cost. What's this box here? That's profit, right? Now, under competitive conditions, we have average total cost, marginal cost, right? And in the optimal situation, right, or the perfectly competitive situation, right, we have P equals MR equals D, right? We set a price that's equal to average total cost. We set a price, the producer chooses to set the price at MR equals MC, but that is actually where it equals ATC, where it equals its average total cost, right? So there's no excess profit. Here we have excess profit. We're setting MR equal to MC and we get excess profit. That's our monopoly profit, right? Monopolists will do this. They face a downward sloping demand curve and they will choose to set their price where they generate a profit. If they set their price instead where price is equal to average total cost, that would be way out here, right? Which would be the same as here, because here you have price is equal to average total cost. Well, when price is equal to average total cost for a monopolist, it's actually over here, not where MC equals MR, but where ATC equals demand, right? So in this case, in the competitive case, ATC equals demand, where MR equals MC, right? That's the competitive outcome that we expect. Monopolists are not going to do that, right? Because if they did that, how much profit would they have? If they set their price to 2 and their cost per unit is 2, so for every unit they sell, they get $2 and it costs them $2 to make it, how much profit are they going to make? 0. Thank you, Kate. Right. But we would set, what we said in this class is average total cost from an economic perspective includes normal profits. So if it was normal for this business, which is making chemotherapy drugs, to make a profit of 10%, if the average business made 10% profit, right, that would happen out there where the marginal cost, which is equal to the average total cost, crosses the demand curve. So what quantity would that be at? Well, we have the formula for the demand curve, right? It's P equals 10 minus Q. And we have the formula, and we know what the average total cost is. It's 2, right? So if we set P equal to 2, what would this quantity be? So what quantity are we going to get when the average total cost line crosses the demand curve? Well, it's going to be 2 equals 10 minus Q, Q equals 8. Good. I'm going to refer to this as Q competitive because that mirrors the outcome for a competitive market. So we have the profit maximizing quantity, which would be the monopolist's choice. We could call that Q monopoly, right? And then the Q competitive would be where the monopolist would set quantity equal to average total cost. And that would be the competitive outcome, right? Let's look at the effects. How much consumer surplus under monopoly? How much consumer surplus does the community get if the monopolist gets to set the price at the profit maximizing quantity to get the profit maximizing quantity? What's the consumer surplus? You can just point at it on the graph or tell me where it is on the graph. So consumer surplus is that extra like yay, that extra yay feeling we get when we buy something for less than we thought we'd have to pay for it. Between the 10 and the, it's the triangle, right? Between the 10 and the 6 and over the 4. So it's this. So how much is that? Well, it's 10 minus 6 tall. So that's 4 tall. And it's 4 wide, right? Because you go from 0. It's this wide, 0 to 4. And it's this tall, 10 minus 6. So it's 4 times 4, 16 times 1/2. So 8. So consumer surplus is equal to 8. But what if they produced at a quantity of 8 and charged a price of 2? How much would the consumer surplus be? It would be that whole triangle, right? If we produced at a price of 2, the consumer gets all of this as their surplus. So how much would that be? Well, it'd be 10 minus 2, be 8, times 8. So 8 times 8 is 64, right? Times 1/2, 32, right? So Q competitive, the competitive quantity, right? If we produced here at this price and this quantity instead of here at the monopoly price, we'd get 32. Right? So if we produced that would be my consumer surplus. But how much excess profit would the monopolist get? Nothing, right? So if you're a monopolist, you know, somebody like Kayla, who's a monopolist, right? Always out there seeking profit. What quantity are you going to choose to set at? Are you going to choose to set your quantity where marginal revenue equals marginal cost? Or are you going to set your quantity where average total cost equals the demand curve? Which one are you going to choose? Which one is Kayla going to choose? Let's be honest. What are you going to choose? The first one. She's going to set it where marginal cost equals marginal revenue, right? Because she wants to take all this profit. Well, here's the thing. She sets her quantity at 4, price of 6. Consumers wind up going from, right, this whole thing, they would have CS equal to 32, right? Consumers wind up getting 8. How much profit does Kayla wind up getting? Well, it's 6 minus 2 is 4 times 4. So 4 times 4, 16, right? So Kayla gets 16. That's 24. This whole box has 32 though, or excuse me, this whole triangle, right? If Kayla was to set her quantity at 8, the consumers would get 32. She's very greedy, so she sets the quantity to 4 and a price of 6 so that she can get $16 in profit. The consumers wind up shrinking their consumer surplus from 32 to 8. She gets 16. That 8 and 16 is 24. What happens to the rest of the 32, right? 32 minus 24 is 8. What happens to all that consumer surplus? What do you think? Dead weight loss. You have no idea? Thank you, Sophia. Sophie, right? It's dead weight loss. This is the dead weight loss. We'll stop on that. So there's a dead weight loss here. What happens? Kayla sets her price at where marginal revenue equals marginal cost so that she can generate a profit for herself, right? Consumers go from getting 32 in consumer surplus down to 8. She gets 16. There's 8 dead weight loss as a result, right? 32 minus 24 equals 8. That becomes the dead weight loss. Kayla puts a dead weight loss on society so that she can make profit. All right, that's the majority of chapter 13. So I need to put together homeworks for that and for both 12 and 13. I'll try to get those out this weekend and you can have, next week to work on them. All right, we'll stop here, right? We'll stop at 12. We come back at 12, right? Yeah. Oh my God. All right. I have so much going on. I just can't keep track. All right. See you in 40 minutes. What am I doing? Oh, shit. You all ready to see? All right. Hey, no, that's great. Let's keep going. All right. Oh, no. You young scholars almost had me. All right. Good. I'm glad. That means I can keep going. Well, that just means we can, let me see. Hold on. All right. Blah, blah, blah. I mean, we're actually doing pretty good. Okay. So in a more complex formula, right? Let's keep the same, downward sloping demand curve. Let's say price is still equal to 10 minus Q. Total revenue is equal to 10Q minus Q squared, right? Marginal revenue is still equal to 10 minus 2Q. Right. But now let's say total cost is equal to 10 plus 2Q, right? What does average total cost look like now? We go to 1240. Wow. We're going to let me just, yeah. All right. Taking advantage of an old man. There's early Alzheimer's setting in. All right. It's all right. I start wandering around. You all wouldn't even notice. Like, I'd just be like, oh, he's going off again. Okay. So what's average total cost and marginal cost? Let's start with marginal cost. What's marginal cost? What happens to a constant when we take the derivative? That's what we're doing. It's called taking the derivative. When we take the derivative of total cost, when we apply the power rule, what happens to the 10? It goes to 0, right? So that's gone. And then we've still got the 2Q term, so that just goes to 2. So marginal cost is still 2, right? Why is it still 2? Because if I make 1, it's 10 plus 2 times 1 is 12. If I make 2, it's 10 plus 2 times 2 is 4, right? So that's 14. So going from 1 to 2 is 12 to 14. What's the difference? 14 minus 12 is 2, right? That's the marginal cost. If I go to 3, it'll be 16. If I go to 4, it'll be 18. It's always 2, right? So my marginal cost hasn't changed. It's still 2, right? What about my average total cost? Well, my average total cost is 10 plus 2Q divided by Q, right? So then we get what? Well, what's the formula? You can split an addition problem into 2 parts as long as you keep the same denominator. So you can split this into 10 over Q plus 2Q over Q, right? So now work through that. This is basically what it is, right? There's no doing anything else with that. What about this? Okay, so when we add that 10, that fixed cost term to our cost curve, right? Our average total cost gets a little messier. It's no longer just 2, right? It's actually 10 over Q plus 2. So if I put a quantity of 1, what's my average total cost? Well, if I do a quantity of 2, what's my average total cost? 7, right? If I drop to quantity of 5, what's my average total cost? Right. So it's what's happening. It's decreasing. If we go up to 10, what happens? So there's no increasing, right? It just keeps going down. So now we have that same so what's the gap between, well, no, that's not true. I want to say that. So it's always going to be a little bit above marginal cost, right? As we draw it down, it doesn't quite ever get there until we go out all the way to infinity, at which point that 10 over Q term goes to 0. It's always going to be a little bit above. So when you have a total cost function with some fixed cost, your Q competitive is going to be based on where the average total cost crosses the marginal cost, crosses the demand curve. Okay, so it's a little left, right, as a result of the additional fixed cost. So your total cost then would be slightly larger. Because you're going to draw that Q competitive up to there and then over. All right. We will, I want you to be able to draw that graph, but for the problems that I will give you, we'll just kind of do the easier version where we use marginal cost is equal to average total cost, just because it makes the math easier. But I want you to understand, and you need to be able to draw this graph that shows that the competitive quantity is slightly different than if the average total cost is not equal to the marginal cost. All right. I don't have another example. I want to make an example up then. So let's imagine we've got, what was the one we did? We'll play with that. All right, let's go back to this one. So we'll use a demand curve of 50 minus 1/2 Q, right? And we'll just say that total cost is equal to 10Q. So we know all this stuff already, so you don't have to recalculate it. What is the profit maximizing quantity that the monopolist will use? Kayla's out there again, doing her thing. What's she going to set? What quantity is she going to choose? No. So if we know total cost is 10Q, what's marginal cost? Because Hannah, she's going to try to maximize her profit, right? So what if her total cost is 10Q, what is her marginal cost? 10, right? Because that's 10 to the Q, 10 times Q to the 1. Bring the 1 down, 1 times 10 times Q to the 1 minus 1 becomes 1. So it's 1 times 10 times 1. So marginal cost is 10. Then what does she do, Hannah? When she's trying to find her profit maximizing quantity, she's going to set what equal to what? No. MC equals MR, right? We're always going to go for MC equals MR. So we know MC is 10, and we know MR is 50 minus Q. Yeah, now we just solve. It's a pretty simple one, right? So Q is equal to 40. All right. So let's draw this. So we know P is equal. So if we draw this, right, let's start with the demand curve. So we know when Q is equal to 0, P is equal to 50. And then when P is equal to 0, we've got to solve for Q. So a half Q equals 50. So therefore Q would equal, right? So we're going to solve for P equals 50 minus 1/2 Q. And I'm trying to find the intercept over here. So I set P equal to 0 because if it's going to be on the Q axis, right? P is equal to 0, 50 minus 1/2 Q. I add a half Q to both sides. I get half Q equals 50. What do I need to do to get rid of the half Q? But you can divide by a half. You could do that. That's kind of messy. Times 2, right? Multiply both sides by 2. Then that cancels. And you get Q is equal to 100. Okay, so that's 100. So we can draw our line down. That. And then we say, all right, we know that MR, excuse me, MR is equal to 50 minus Q. So if MR is equal to 50 minus Q, when Q is 0, MR is 50, right? So it's there, starts there. And then when MR is 0, right? So we're going to put MR on the P axis. When MR is 0, 0 equals 50 minus Q, then where does it cross the X axis at? Molly. I just add Q to both sides and I get Q is equal to 50. Here's a quick cheat that you can memorize. What are you seeing in the pattern here with MR? We had the demand curve crosses at 100. The MR crosses the x-axis at 50. Here we had the demand curve crossed at 10. The MR crossed at 5. What's the rule? It's half of whatever Q is, right? So for this class, we will always have, when you're doing downward sloping demand curves, the MR will always be half of whatever the Q is when price is zero. Okay, so you can just kind of, if you figure out, oh yeah, it's Q is 100 when price is zero, then the MR is going to cross the Q axis or the X axis halfway between. So if the Q is 80, the MR would cross at 40, right? If Q is 60, MR would cross at 30. Okay, so you get it. So now we said our marginal cost is 10. So we could just 10, and what do? Draw straight line, right? Well, horizontal line, they're all straight, but right, horizontal line, right? Where MC, right? And MC, in this case, what's ATC? Well, ATC is TC is total cost divided by quantity. So ATC is also 10, right? All right. And then we just said the profit maximizing quantity is 40, where marginal cost, right? Where marginal cost crosses marginal demand, marginal revenue. We'll call that monopoly. You can still keep calling it profit maximizing quantity if it's easier for you to remember, it's fine. But that will be the quantity that the monopolist creates. What's the price the monopolist is going to charge? Up here. That's your demand. So Kayla's going to make 40 units. What's the price she's going to charge for those 40 units? Right. So what's that going to be? 30, right? Because we get P equals 50 minus 1/2 times 40. 1/2 of 40 is 20. So 50 minus 20 equals 30. So she's going to charge a price of 30. Okay. What is the consumer surplus? What is Kayla's profit? What is the deadweight loss? So let's start with the consumer surplus. Where is the consumer surplus? Molly. And right, it's this triangle here, right? So this triangle is the consumer surplus. It is the area of the demand curve, the area above the price and below the demand curve. So this is my consumer surplus. So how much is it? Well, it is 50 minus 30, tall, right? It's how wide? 40. So 50 minus 30, 20, times 40, 800, times 1/2, 400, right? 50 minus 30, right? That's this, the width is down, you go down here to 40, times 1/2. That's 20 times 40 is 800, times 1/2 is 400. So consumer surplus is 400. How about Kayla's profit? Somebody other than Molly. Like Linda. How much is Kayla's profit? Can you point at it? Okay. And 40. So it's the box. It's this box here. Right. So the profit then is 30 minus 10 times 40. And it's a box, so that's it. So that's 20 times 40, 800. How about the deadweight loss? Can somebody point at the deadweight loss? Allie. At the top? Is that what you said? This triangle? No, that's the consumer surplus. Hannah? Yeah. Why is that the deadweight loss? Other than we've memorized that that's where it is. Where's Q competitive, Kayla? Where could you set the price if you were a more generous-hearted soul? No. Graphically, we haven't actually calculated it. Where what is equal to what? Right. It's going to be here where the demand curve is equal to average total cost, right? So that's our Q competitive. So if Kayla was a person of, of great caring, and not just worried about, her profits, then she would set the price equal to the average total cost, right? And produce Q competitive. So we could have Q competitive, but because Kayla really just wants profit and doesn't care about the rest of us, she's going to set price at 30, quantity at 40, right? Which means we get Q competitive minus Q minus 40. We lose that many units of whatever this is. Let's say it's, insulin for babies or something like that. She just doesn't care, right? So we get whatever Q competitive is minus 40. That's lost, right? Hence deadweight loss. So that's all the, if she produced at Q competitive, the consumers would get this whole triangle as their consumer surplus. So if she produced here, the consumer surplus would be all of this. The price would be 10, and the consumers would get everything above the price and below the demand curve. Since she actually produces at 40, she squeezes the quantity in, and we lose all this quantity, right? And she gets this big profit. And the result is a deadweight loss. Nobody gets that. Kayla doesn't get the deadweight loss. The consumers don't get the deadweight loss. Nobody gets the deadweight loss. That's the nature of deadweight loss, is nobody gets any of that. All right. So we said how much she makes in profit. How much is the deadweight loss? Well, in order to figure that out, we need to know what Q competitive is. So how do we figure out what Q competitive is? Good. So we're going to set this point is the intersection between marginal cost or average total cost and the demand curve. So we just take the demand curve and we set it to 10. So 10 equals 50 minus 1/2 Q, right? Add a half Q to both sides, subtract 10 from both sides. We get 1/2 Q equals 40. And then to get rid of the 1/2 Q, we're going to do what? Times 2. So the Q competitive would be 80. So then the deadweight loss then is 80 minus 40. We could have had an additional 40 units if Kayla was nicer, right? Maybe the ghost of Christmas future will come down and make her, relent a little bit this season. We'll see. Is there a new Christmas Story movie coming out with Will Ferrell or something? I think I saw a trailer. Yes. All right, you should go watch it. Yeah. All right. So how much quantity is lost? 80 minus 40 is 40. So that's the base of the triangle times the height of the triangle is how much? I'm talking about the deadweight loss. So the height of the triangle is 20, 30 minus 10, right? 20. 30 minus 10, right? That's the height. And then the width is the competitive minus the monopolist quantity or the profit maximizing quantity, however you want to write that. 80 minus 40, right? Times a half. So it'd be 40 times 10, excuse me, times 20 is 800, times a half is 400. So it happens to be right the same as consumer surplus. So deadweight loss is also 400. All right. So we talked about why we talked about natural monopolies. There are some things that have this cost structure that has a declining cost, but not everything that has a monopoly in our society, not everything that's monopoly in our society has is a result of a natural monopoly. Can you think of? You don't want to close your notebooks just yet. You want to write this down because there'll probably be a question on the exam about this. Right. So this is a little bit more theory. So we talked about things like power production. You guys told me it's 12:40. I got like a lot of time now. 12:30. Wow. All right. Well, I got 3 minutes. All right. So don't close up the books yet. We're going to do this real quick and then we'll be done. All right. We talked about natural monopoly, things like power production. Usually utilities fall into the, I had a lot on my mind. Power production, mostly like utilities, right? They're things that have a huge fixed cost, and then your additional variable cost tends to be very low, right? So the cost of running water to you once I've built all the pipes, right, and I built the purification plant is really cheap. So the variable cost, the cost of additional units is really low, but the initial setup is huge. That's a natural monopoly. But there are monopolies out there that aren't natural, right? Meaning they don't come about as a result of the cost structure. So where do those come from? Well, patents are a form of a government granted monopoly. So if Allie invents a new drug that cures cancer or something like that, right? She would patent it, and then the government would give her a patent that would say only Allie can produce this drug for a period of 20 years, right? And so if Shayla decides, I'm going to, I can just look up the patent, and it's got the description of the drug, and I'll just, go to my secret laboratory underneath Hewitt and start making this drug and selling it. The government will come in and Allie will be able to file suit against Shayla, and she will win, and she will take all the money that Shayla made from selling Allie's drug, right? Because Allie has a monopoly, government granted monopoly. So patents are an example of a government granted monopoly. Write that down. Patents are an example of a government granted monopoly. Give me another example. We're just talking about a movie. Can you copy a movie and just like sell it? Right? What's that called? Copyright, right? So copyright is another form of a government granted monopoly, right? So if you make something like a movie, right, or you write a book, or you write this amazing book about health economics, for example, and you publish it, nobody gets to just copy it and then start selling it, right? Shayla can't go ahead and take your book and go to a photocopier and start making copies and selling them, right? So that's another example of a government granted monopoly. And I believe it's like for copyright, it is your lifetime plus 75 years. So like I think like Winnie the Pooh just came off of copyright, like the original Winnie the Pooh. I think you could like make images now of Winnie the Pooh, right? But not with the red shirt, because that one came later. and is still under copyright. So you could draw, and you can even use the word Winnie the Pooh, and you can sell stuff. So you could make a T-shirt, write Winnie the Pooh on it, and as long as he's not wearing the red T-shirt, you could sell that. And the family, I can't remember the name of the guy that made Winnie the Pooh, can't sue you. But if you put the red T-shirt on, that's still under copyright. Okay. So those are two examples of government granted monopolies. All right. Now I'm really done. I'm gonna really see you at 1:10, right? God. Oh. Ma'am, 1 second. Let me just stop the recording.